Alrighty, problem number 4. This is a non-calculator problem. The height of a tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. So part A says to use the data in the table to estimate h prime of 6, and then using correct units, interpret the meaning of h prime of 6 in the context of the problem. So we have two things. We want to estimate this, and then we need to interpret the meaning. Okay, so if we are looking for h prime, that is a derivative, and we know that a derivative is the slope, and so I'm looking for the slope at 6. And notice I can't find the slope at 6, but I do know that the time being between 5 and 7, 6 is right in the middle there, so we're going to use these 2 points, and we are going to be finding the slope. So to find h prime of 6, we can do y2 minus y1 over x2 minus x1. So we'll have 11 minus 6 over 7 minus 5, which will give me 5 over 2. We could leave it as 5 over 2, or we could make it 2.5, your choice. And let's see if I look at my units. Since this is a slope, it's just the y value over the x value. So my y units are meters per, and then my x value is years, so 2.5 meters per year. And when it asks us to interpret the meaning of a derivative, something is changing. So since we're finding the derivative of h is going to be changing. So what did h represent? H represented the height of the tree. So we're going to start out, our interpretation will be at t equals 6 years. Okay, what is changing? The height of the tree is changing. The height of the tree. And instead of just putting that it's changing, is it increasing or decreasing? Since I have a positive slope or derivative, I know the height of the tree is increasing. And then I need to say how fast it is increasing. It's increasing at a rate of 2.5 meters per year. So you might just want to make yourself a little note on that. Whenever it asks you to interpret the meaning of the derivative, we want to say when it's happening. We want to say what is changing. And the third thing, at what rate is it changing? So if you could just write that somewhere, or just write it in your notes, pause it and take a minute and do that, that would be great. Okay, so the points that we would have gotten, if we would have ended up getting 2.5, we would have gotten a point, and I wouldn't worry about units on that. We just needed the 2.5. The units are going to be counted in the second part of this. In the interpretation, if you had units in your interpretation, you would have gotten 1 more point. Okay, for part B, explain why there must be at least one time between 2 and 10 such that h prime is equal to 2. Okay, so as soon as I see something about a derivative and I see something about an interval, that always makes me think of the mean value theorem. So basically it's asking us to show that the mean value theorem is going to apply. So if we're going to use the mean value theorem, what we want to try to do is find somewhere, if you remember that the average rate of change, or the slope, is equal to the instantaneous rate of change, or the derivative. Okay, so they've already told us that the derivative is equal to 2. So we want to see, is there some place where the average rate of change, or the slope, is equal to 2, somewhere between 2 and 10. And when I first did it, I tried just from 2 to 10. And if you end up doing that, you end up getting 13.5 over 8, and that definitely doesn't equal 2. But then if you look at looking at between 3 and 5, and that is in the interval 2 to 10, if I were to find the slope between 3 and 5, 6 minus 2 is 4, and then 5 minus 3 is 2, and that reduces to 2. So I was able to find a spot in that interval where the derivative was 2. So now I'm going to just show that if I did h of 5 minus h of 3, and I divided by 5 minus 3, again, I'm just finding the slope, that would give me 6 minus 2, 5 minus 3, which gives me 4 over 2, which gives me 2. So since I found that, I did find a place. And so if I found a place where the average is equal to 2, then we, by the mean value theorem, automatically know that the derivative must also equal 2. So that's really where they were driving for on this problem. But in order to say that, in order to use the mean value theorem, the function has to be differentiable and continuous. So I'm going to say, since h of t is differentiable, implying that it is also continuous, because something can't be differentiable if it's not continuous. So we have to include both of those words. So since it's differentiable, implying that it is also continuous, that could also say because it's continuous and differentiable, whatever, the mean value theorem guarantees that somewhere on the interval 2 to 10, h prime of t equals 2. And again, I was able to say that because I did find a spot where the average value was equal to 2. So that was kind of a tricky problem. So that it is what it is. All right, so if you actually found an average rate of change or a slope, and you found that it was equal to 2 somewhere on the interval, you would get a point. And then if you were able to justify your answer, making sure that you said something about the function being continuous and differentiable, you would get that second point. Alrighty, part C, use a trapezoidal sum with the 4 subintervals indicated by the data in the table to approximate the average height of the tree over the time interval 2 to 10. All right, so first I have to see 2 things. Trapezoidal sum, 4 subintervals. So I know I'm going to have 1 interval, 2 intervals, 3 intervals, 4 intervals, so not equal. So I won't actually use a trapezoidal rule. I'll have to split them up. And then the second thing we can't forget is that it didn't ask for the height of tree, it's asking for the average height of the tree. So we need to make sure that before we're done, we do put 1 over b minus a out front, which is going to be 1 over 10 minus 2, which is going to be 1/8. So before I'm done with my problem, I have to make sure that I multiply it by 1/8. So when I set it up, I'm just going to put the 1/8 in there so I don't forget. So the first trapezoid is going to be 1/2 times the height, which the difference between 3 and 2 would be 1. And then sum of the bases will be 1.5 plus 2, and then plus 1/2 times the height. The distance between 3 and 5 is 2. The sum of the bases, 2 plus 6, plus the third one, 1/2 the height. The distance between 5 and 7 is 2. The bases are 6 plus 11. And then the last one, 1/2 times the height. The distance between 7 and 10 is 3. And then the sum of the bases, 11 plus 15, okay? Now, if I left my problem just like this and didn't even work it out, I would get all of my points because it is going to be equivalent to the correct answer, but I am going to go ahead and go a little bit farther than this. So I am going to have, on this part, I'm going to end up getting 7/4. On this part, I end up getting 8. On the third part, I end up getting 17. And the fourth part, I end up getting 39. Okay, and I'm still multiplying that by 1/8. And again, if I left my answer at that part, I'd be fine. I went a little bit farther. If I added those together, I got 64 3/4, still times 1/8. And if you decided to go any farther than that, we'd get 263 over 32. And it was the average height of the tree. So I need a height of the tree. It would be meters. Okay, so again, if you left your answer just like this, kind of almost preferred, because then you're not worrying about making any mistakes in the middle of it. Okay, so you are going to get 1 point for using this trapezoidal sum. So if you show this work right here, you would get 1 point. And then if you ended up getting a right answer, which would be making sure that you multiplied by the 8, the 1/8, you would get another point. Okay, part D. The height of the tree in meters can also be modeled by the function g, given by g of x is equal to 100x over 1 plus x, where x is the diameter of the base in meters. So let's just keep that in track here. Okay. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? Okay, hopefully you're seeing some keywords in there. Something is increasing at a rate of something meters per year. It's asking me for the rate of change of the height of the tree with respect to time. So this is definitely a related rates problem. So I'm just going to write down the given. The first of all, they told me that the tree is 50 meters tall, and that this time h is not the height. This time the height is g, so I know that g is equal to 50. They tell me the diameter of the base of the tree, so x is the diameter of the base of the tree. The base of the tree is growing at the rate of 0.03, and it is increasing, so that will be a positive number. And then it says, what is the rate of change of the height of the tree? So they are asking me for dg dt when the height is 50 meters tall. So I have all my information down. So I need a formula. Well, if everything is related to g and x, I have a formula for g and x. So I'm going to write down my formula, which is 100x over 1 plus x. We're going to take the derivative of each side. Well, remember when we take the derivative, if it's a related rate, everything will be involved with a t, like a dt. So this side will now be dg dt. To do the right side, I notice that it's a quotient, so I'm going to have to use a quotient rule. So my f prime will be the derivative of 100x will be 100. And then I do need to include the dx dt. And then g prime, the derivative of 1 plus x will be 1 dx dt. So we do need to make sure every time we take a derivative, it's always with respect to time. So now when I'm using the product rule, I'll get f prime times g, so 100 dx dt times g minus f g prime, so 100x times dx dt all over g squared, 1 plus x squared. All right, and now we're just going to be trying to find dg dt. So I'm going to try to plug in information. I do notice that I have information for dx dt, but I do not have information for x. So we're going to get to do a little side trip. And we do know that, so I'm going to use this formula. G is equal to 100x over 1 plus x. We do know that g is equal to 50. So I'm going to go ahead and solve this for x. I'm going to cross multiply. So if I cross multiply, I'm going to get 50 plus 50x is equal to 100x. I'm going to subtract 50x from both sides. So I'll get 50 equals 50x. And so x will equal 1. So now I know my x is 1. So now my dg dt is going to equal 100 times 0.03 times 1 plus 1 minus 100 times 1 times 0.03 all over 1 plus 1 squared. Now, if you don't want to calculate this incorrectly, you could leave your answer just like that and you would get all of your points. If you did go down to a final answer, you will end up getting 3/4. We do need units on it. So if I'm talking about the rate of change of the height of the tree, the height was measured in meters and the time was measured in years. So it would be meters per year. Okay, so points that we would have gotten on that one, we're actually going to get 2 points for finding that derivative. And then we would get 1 point for getting down to this answer, plugging in the 1 in the 0.03. So that is problem number 4.